In this video, I will discuss about the correlation analysis. There are lack of situations which get conclusions using one variable in the business field and also in our day-to-day life. We have to work with more than one variable and also more than one data set and have to get decisions on relationships among those variables. It is important to examine whether there is a relationship between two variables in decision making in many practical fields. Correlation analysis and regression analysis are two of statistical techniques which are mostly used to achieve that purpose. Here I will discuss about the correlation analysis. First, we will consider about the basic concepts on correlation analysis. Then correlation analysis and simple linear correlation. Next, measure and express the correlation. Then scatter diagram, product movement correlative coefficient. Finally, we will calculate the product movement correlative coefficient for both grouped and ungrouped data. Let's consider about the correlated variables, which is also known as interrelated variables. If there's a clearly defined relationship among the pattern of distributions of two variables, those variables are known as correlated or interrelated variables. As examples, age of a person and his intelligence level, and price of a goods and its quantity of demand. In our real life, there are some fertile relationships among the variables. If any change in one variable doesn't have any influence on another variable, those variables are not correlated or interrelated. As an example, height of a pupil and number of brothers and sisters he has. We don't use such variables for analysis purpose because those are useless. The next concept is correlation. If there are two variables and one of that variable affects to the other variable, it is known as correlation. When we consider the concept of correlation, there are various types of correlation as linear, nonlinear and so on. Here we will only discuss about the linear correlation. Simple linear correlation. If there are two variables and one of that variable change proportionately to the change of other variable, it is known as simple linear correlation. In making decisions at various stages in any practical field, most probably a study is launched to check whether there is a relationship between two variables. The concept of correlation is more important in that context. Let's see an example from business field. If the sales of a particular product depends on the cost of advertising, it may be comprehended that the sales could be promoted by allocating a considerable amount of money on advertising. Since the dependent variable can be estimated by expressing the correlation between two variables in a mathematical function, the concept of correlation is the more useful in making production plans and estimations at that context. Measure and express the correlation. Correlation between two variables can be expressed in several ways. First one is express the correlation using statement. It can be expressed the correlation between price of product and the quantity of its demand as once the price of product increases, decreases the demand for that product, and also when the price of product decreases, increase in the demand for that product too. Therefore, there is a negative correlation between price of product and the quantity of demand of that specific product. Although this is the simplest way of expressing the correlation between two correlated variables, but it couldn't have an idea about the strength of the correlation because there is no any quantified measurement. Then we use the second way as represent the correlation using scatter diagram. Third way, express the correlation using quantitative measures. First one is Carl Pearson's product movement correlation coefficient. It can be used when the correlated variables are in quantitative manner. And next one is Spearman's rank correlation coefficient. It can be used when the analysis uses the ranks of non-quantitative variables, non-quantitative values in the case of correlated variables are in non-quantitative manner. Let's see about the scatter diagram. When the ordered pairs or the observations points related to pairs of variables are plotted on a coordinate plane, the chart derived is called as scatter diagram or scatter plot. When we construct the scatter plot, first we have to identify the independent and dependent variables. Clearly, we have to identify independent and dependent variables. And then, accordingly, we have to name the coordinate axis. As example, the independent variable should be represented on the horizontal axis and the dependent variable on the vertical axis. And finally, we have to plot the observations of the points related to the pairs of variables on the coordinate plane. Let's consider an example. Following table expresses the data about the advertising cost and quantity of sales of specific product. Construct the scatter plot on those data. These are the data. Independent variable is advertising cost and dependent variable is quantity of sales. This is the scatter diagram. You can see that here I put the topic and name both axes with the units. That means advertising cost in thousands of rupees and quantity of sales in thousands of units. And mark the points in coordinate plane. As for the data which you use, you can use the breaks for axis as your necessity. You should remember that the scatter diagram only consists of scattered dots. There is no need to draw the regression line on scatter diagram. As usual, there are both merits and demerits of scatter plots. We can use scatter plot to decide relationship between two variables are linear or non-linear, and to decide relationship between two variables are positive or negative, and to understand the strength of relationship between two variables. But as we have shown here, scatter plot doesn't give the quantified measurement on relationship. So we can't use scatter plot for comparison purposes. Next, see the types of relationships. One can identify linear relationship or nonlinear relationships and also non-related variables used in the scatter plot. First one is linear positive relationship. If the values of dependent variable also increases when the independent variable increases, or if the values of independent variable also decreases when the independent variable decreases, there is a positive relationship between those two variables. In such a situation, all the points in the scatter diagram may fall on or closer to straight line which rising from left to right. This is the perfect positive relationship. Here all the points are lay on the line, and this is the strong positive relationship. Most of the points are lay on the line or very closer to line. and this is the poor positive relationship. Some of the points are laid closest to line and as well as far from the line. The next type is the linear negative relationship. If the value of dependent variable decreases when the value of independent variable increases, or if the value of dependent variable increases when the value of independent variable decreases, there's a negative relationship between those variables. In such a situation, all the points in the scatter diagram may fall on or closer to straight line, falling down from left to right. Here also perfect, strong and poor relationships. This is the perfect negative relationship, and this is the strong negative relationship, and this is the poor negative relationship. The next type is non-linear relationship. In the sense when there is no relationship between two variables and there is no linear relationship between two variables, the changes in each variable occur independently. At such situation, a clear linear relationship is not observed and represented on scatter diagram. So we can identify nonlinear relationships as here. In third way to express the correlation is the using quantitative measures. First one is Carl Pearson's product movement coefficient of correlation. It can be used when the correlated variables are in quantitative manner. And second one is Spearman's rank correlation coefficients. It can be used when the analysis uses the ranks of non-quantitative values in the case of correlated variables are in non-quantitative manner. Here only consider the Carl Pearson's product movement correlation coefficient in this video, and we will discuss rank correlation coefficient in next video. Product movement correlative coefficient. The linear correlation between two quantitative variables is evaluated using the product movement correlative coefficient. And product movement correlative coefficient denoted by the simple R. The size of correlation is determined on the value of R. As this figure shown, if the R equals 1, there's a perfect relationship. R equals positive 1, positive perfect relationship. R equals negative 1, negative perfect negative relationship. And R is closer to 1. That means R is lay between 0.75 to 1. There are strong relationships. And R lays among the 0.5 to 0.75, there are moderate relationships. And if the R is between the 0 to 0.5, there are poor relationships, poor correlation. If the sign negative, negative poor, and the sign positive, positive poor relationship. If the R equals 0, there is no linear correlation. There is no linear correlation. It may have non-linear correlation, but there is no linear correlation. Next, see the features of correlation. First one is product movement correlative coefficient lay the range of -1 to +1. As we discussed about, if the product movement correlative coefficient takes the value equals or more than 0.75, there is a strong linear correlation between two variables. And if the product movement correlative coefficient takes the value 0, there is no linear correlation between those two variables. And second one is product movement correlative coefficient is a measure of dimension. When the independent variable increases, increase in the dependent variable, or when the independent variable decreases, decrease in the dependent variable is known as the plus or positive correlation. And also when the independent variable increases, decrease in the dependent variable, or when the independent variable decreases, increase in the dependent variable is known as minus or negative correlation. And also the linear correlation can be identified in two directions as plus and minus using the product movement correlation coefficient. So we call that product movement correlative coefficient is a measure of dimension, positive or negative, plus or minus. Third one is product movement correlative coefficient is independent from units of measures. Imagine when we express the summary statistics such as mean, mode or median, there we use the unit of measurement. As an example, if we express mean value related to weight of students, we use kilograms, such as 50 kilograms, 55 kilograms, or so on. But in the case of correlation coefficient, there's no units of measurement. Fourth one is, if there's a nonlinear relationship between two variables, product movement correlative coefficient equal to 0. And product movement correlation coefficient equal to 0 when two variables are independent. But we can't identify that two variables are independent when product movement correlative coefficient equal to 0. There may be another reasons for the 0 value of product movement correlative coefficient. We can say only the product movement correlative coefficients equals to 0 when two variables are independent. Sixth one is, if there are only two pairs of observations, there is perfect correlation among those variables. As we know, we need at least 2 points on coordinate plane to draw a line. If there are only 2 points, we can draw a line using those points. So those 2 points definitely lay on the line which we draw. Therefore, if there are only 2 pairs of observations, there is perfect correlation among those variables. And seventh one, product movement correlative coefficient is stable, not change when it changes the values of variable or variables by constant ratio. As an example, suppose there are two variables known as x and y, and correlation between x and y is r. Then the correlation coefficient between 2x and y, or x and 2y, or 2x and 2y is not changed. Likewise, product movement correlative coefficient is stable, not change when it changes the value of the variable or variables by constant ratio. Product movement correlative coefficient is stable, not change when it changes the values of variables by constant value. And the last one, product movement correlation coefficient equals to 1 when the dependent variable is multiplier of an independent variable. As an example, suppose their x values are 1, 3 and 5, where the y values are double of x. That means here y values are 2, 6 and 10. Here correlation between these x and y variable should equals to 1. As we discussed about product movement correlative coefficient denoted by R, and we can calculate using these formulas. For ungrouped data, first formula is this, and the second one, and if we have summary of mean deviational data for both variables x and y, we can use third formula. For ungrouped data, we can use any of these three formulas. As my experience, first one is easy to use. This is the formula for group data. Here simple x is the mid value of variable x and simple y is the mid value of variable y. And we can get the dx value as this. Here a is assumed mean of the variable x, and c is the class width. Let's see the hypothetical example for both conditions, for ungrouped and grouped data. First, ungrouped data. Following table shows the data about number of life insurance sale by brokers and incentives they earned during last week. Compute and interpret the product movement correlative coefficient. Here X is the number of life insurance and Y is incentives. We have to find the summation of X, summation of Y, summation of X squared, Y squared and XY. It is easy to add some columns to table and get answers step by step. Further, it can be helpful if we want to double check our answers. Here I get the summation of x and y and also add the 3 columns to fill the values of x squared, y squared and xy. The x squared column, we have to fill the squared values with each element in x column. Squared value of each element in x column. First one is squared of 20 equals to 400. And squared of 18 equals to 324. So on. And then get the summation of this column to get sigma x squared. Here 3005. And next we have to fill y squared column. First value of y is 3 and squared value of 3 is 9. Likewise, we can fill the y squared column. Squared value of 2.3 is 5.29 and so on. Then get the summation of this column to get sigma y squared. Here 58.76. For the last column x and y, x times y, we have to fill the x times y values with each element in x and y column. First one is 20 into 3 equals 60. And then 18 into 2.3 is equals to 41.4 and so. Then finally we have to get the summation of this column to get sigma xy value. Here 419.7. After we got the summation of table, that means sigma x, sigma y, sigma x squared, sigma y squared and sigma xy, we can apply them into formula. These are the summations we have get from that table. This is the formula. Here n is the number of observations we have. Here 8. We have find the summation of x, y, x and y. In the denominator, sigma x squared is summation of x squared column. And the squared of sigma x is squared value of the summation of x column. And as well as sigma y squared is summation of y squared column and squared of sigma y is squared value of summation of y column. Then I applied the data. After simplify up to this step, if we doing calculations manually, it is bit difficult to get answers directly. So it is easy to use log values. So firstly, we have to convert these expressions to log. This is our expression. This is the converted value. Division of natural numbers be subtraction in log, and multiplication of natural numbers be addition in log, and the square root, which equals to half power, is natural numbers be half times log values. After simplify as log values, we have to get anti-log to and convert log r into r natural value. This is the log values. This is the final answer of log values. Then we have to get the anti-log value. And this is the R value, correlation coefficient value. There's one thing to consider. If we get the minus value for numerator in this stage, if we got the minus value for numerator, we can't get the log values. In those situations, we just ignore the minus sign only for this step and complete the log calculations and finally put the answer with minus sign. As our correlative coefficient is equal to 0.98, there is strongly positive correlation between number of life insurance sold by brokers and incentives they earned during last week. This is an example for group data. Following table shows the data about number of life insurance sales by 40 brokers, number of insurance sales by various insurance sales by 40 brokers, and incentives they earned during the last week. Compute and interpret the product movement correlative coefficient. Here you can see both x and y values are in interval as intervals, class intervals. We have to draw another table like this. It is easy to get summation using this table. So first put the class intervals of x values in top row. This top row we can see the class intervals of x values. And second row, simple x means mid value of x class intervals. Capital X is class intervals of x values, and simple x is mid values of those class intervals. As an example, first class interval is 0 to 10 and we can get mid value as 5, which get from the 0 plus 10 equals 10 divided by 2. And second x class interval is 10 to 20. 10 plus 20 equals 30. 30 divided into 2 is equals 15. Likewise, we can compute the row, x row. And then we put the y class interval to very first column, and second column is the class midpoints of y, simple y. As example, first y class is equals to 0 to 6. 0 plus 6 equals to 6, and 6 divided to 2 is 3. Likewise, we can complete the simple y column. And middle area, I put the frequencies given our example, and 40 is the summation of all frequencies. Here let's see the dx row. Here we have to assume a mean and put 0 against that assumed mean value for x. Then get coordinate deviating values. As example, for x value 5, we can get dx by 5 minus 15, which is assumed mean, and divide by class with 10. Get answer minus 1. And let's consider the x values 25. 25 minus 15 equals 10, and 10 divided by 10 equals 1. Likewise, we can complete the dx row. And then we have to consider the y row, dy row. dy column. Here also we have to assume a mean for y and put 0 against that assumed mean, then get coding deviation value. As example, for y value 21, we can get the dy value by 21 minus 9, which is assumed mean of y, and divide by class with 6. Get answer plus 2. Likewise, we can complete the dy column. In next step, we have to get joint frequencies for each and every frequency value. We can get joint frequency by multiplying frequency value by both dx and dy values. As an example, joint frequency for first frequency value can be calculated by dx value minus 1 into dy value minus 1 into frequency 8. The answer is plus 8. In second frequency value, dx is 0, dy is also 0, frequency is 5. Multiplication of 0, 5 and 0 is 0. So joint frequency is 5 is 0. Likewise, we can complete all joint frequencies. I have completed the all joint frequencies. Next, consider about the Fy column. This means frequency for each y class interval. So let's consider the first y class interval, which is 0 to 6. All the corresponding frequencies 8, 5, 1 and 0 belongs to this class. So frequency for this class is equals to 14, which is summation of 8, 5, 1 and 0. Second y class interval is 6 to 12. The frequencies corresponding frequencies is 2, 2, 4 and 1. 2, 2, 4 and 1 belongs to this class. So class frequency is equals to 9. Likewise, we can complete Fy column. Next, consider about the Fx row. This means frequency for each x class interval. So let's consider the first x class interval, which is 0 to 10. All the corresponding frequencies 8, 2, 1 and 0 belongs to this class. So frequency for this class is 11, which is summation of 8, 2, 1 and 0. Second x class interval is 10 to 20. 5, 2, 2 and 0 belongs to this class. So class frequency is equals to 9. Likewise, we can complete the Fx row. Let's see the Fy dy column. This means multiplication of each dy elements by corresponding Fy values. First Fy dy value minus 14 comes from minus 1 into 14. Minus 1 into plus 14 equals minus 14. Second Fy dy value can get by 0 into 9. 0 into 9 equals 0. Likewise, we can complete Fy dy column. When we consider the Fx dx row, it means multiplication of each dx element by corresponding Fx values. First Fx dx value minus 11 comes from minus 1 into plus 11. Second Fx dx value can get by 0 into 9. 0 into 9. Likewise, we can complete fx dx row. Next, consider fy dy squared column. This means multiplication of each fy dy elements again by the corresponding dy values. First fy dy squared value is 40, comes from minus 1 into minus 40. Second fy dy squared value can get by 0 into 0. Likewise, we can complete fy dy squared column. Then fx dx squared column. This means multiplication of each fx dx element again by corresponding dx value. First fx dx squared value 11 comes from minus 1 into minus 11. Second fx dx squared value can get by 0 into 0. Likewise, we can complete fx dx squared row. Then last column is corresponding row summation of joint frequencies. In first row, summation of joint frequencies is 8 plus 0 plus minus 1 plus 0 equals 7. Second row, 0 plus 0 plus 0 plus 0 is 0. Likewise, we can complete last column. The last row values totally equals to last column values, which is joint frequencies of corresponding column. As an example, in first column, f dx dy value is 8 plus 0 plus minus 1 plus 0, which equals to 7. Likewise, we can complete last row too. Now we have completed table and easily get summaries which we want to apply in formula. Sigma fy dy. Sigma fy dy is equal to 9. Sigma fy dy squared is 49. Sigma f dx dy is 36. Sigma fx dx is 26. Sigma fx dx squared is 52 and joint frequency, summation of joint frequency equals 36. This is the formula and we can apply above calculated summations to this. If you have to calculate manually, you can use log values to doing calculations simply. Otherwise, you can use calculator and simply get the answer. As the R value is equals to 0.743, there is moderately positive correlation between number of insurance sales by brokers and intensives they earned during last week. So in this video, we discussed about the concept of correlation and simple linear correlation, how to draw the scatter diagram and how to interpret scatter diagram. And then Carl Pearson's product movement correlative coefficient, and finally calculations of product movement correlative coefficients for both grouped and ungrouped data. In next video, I will explain about the rank correlation coefficient.